Hello, I'm Arthur. Welcome to my lab. So for years, this Micronta multimeter from Radio Shack was my only meter that I used for all my experiments and designs and measuring everything that I need to measure electronic-wise. It's a great meter, I really love it, but it's beginning to show its age, and I thought that it's time to buy some more meters just in case this one fails. And also, for some measurements, you really need more than one meter to be able to take the measurement. Actually, one of the measurements that I'm planning on making will require 4 multimeters. So I started by buying these 2 meters, and then I have 2 more on their way, just so that I have all the meters that I need to make that measurement, and also have some extra meters in case I need them. So this one is Mastech MS8268. This is one of the cheaper meters that you can buy on eBay. I paid for this one 26 bucks, and that's really on the lower end of the scale of the meters that you'd even want to look at. You really don't want to buy anything much cheaper than that, although one of the meters that I'm waiting for was 23 bucks, so even cheaper than this one. But so far it seems like a good meter, and I'll post a separate video with a review of this meter, and I'll talk about its features. I'll get into more details, and probably will take it apart and see what's inside. One thing that I can tell you right away is that I can see through the holes that it has the dreaded split connectors that Dave Jones of EEV blog despises, and he always says that you know, if that's a sure sign of a really bad meter. But so far this meter is doing fine, and I think for what I need it for low voltage measurements, it'll do the job despite the connectors, and it should be fine. The other meter that I bought is this Victor 86C. This one was a little bit more expensive. It was $42, so still a reasonable price. Certainly not in the $50 plus or $100 plus range that would normally be recommended for a real decent lab meter. And you know, you can spend $200, $300 and more on a really high quality meter, but that's more money than I'm willing to spend, and more of a meter than what I need for my purposes. So these 2 meters should do just fine. And then I hooked them up to some sources of voltage and just wanted to compare them against my original meter, see how close they are in the measurements. And they weren't exactly showing the same measurement. So I ended up deciding to buy the voltage references. And so this is actually what arrived today, and I'm really excited to play with this stuff and show you the results. So I've received today that's one of the features that I find really annoying. These 2 new meters have auto power off or auto sleep feature. So you turn them on, you let them run for a while, and eventually they'll start beeping a warning beep, and then they'll go into power off mode. This Micronta meter will just stay on forever until the batteries run out. And sometimes you really want to keep your meter on and running for an extended period and not have to push a button or something to keep the meter awake. I just ended up having to just push the hold button and then push it again, and that resets the sleep mode. So I find this really annoying in these new meters, and I think I'll try to find a way to disable that so that you can leave the meter on. And this meter, there were times when I forgot to turn it off, and it sat turned on overnight, and well, it's still alive, it's still working fine, so nothing bad happened to it. It just ran out of batteries a little bit sooner, but the batteries in this meter last I don't know, several months to years, so I don't think that's a problem, that the meter occasionally might stay on longer than it should be. So I wouldn't mind replacing batteries more frequently in these meters if they just stayed on when I need them on. But anyway, going back to the main topic. So the 2 voltage references I received today I bought both of them on eBay, and this barebones one, you can actually install a battery in it, and it's recommended to run these voltage sources from a battery and not from a power supply, because power supply can introduce some noise, which may affect then the output voltage of these reference sources. So this one will run on a battery, but I do not have a battery for it, so I just plugged it into this Turnigy LiPo cell, and this is supplying around 13 volts, which is sufficient for this voltage source. You should power it from somewhere around 13, 15. I think it goes up to 20 something volts, but 13 to 15 seems like a good range. And it has some jumpers that you can switch around to adjust your output voltage. It's right now it's set to 10 volt output. It also has 7.5 volt, 5 volt, and 2.5 volt. And it has 2 outputs for your probes. But also what I find nice is it has 2 little loops here that you can put your clip on those loops, or stick your probe through. And so that came in handy, because now I can plug in all of my meters fairly cleanly to do my measurements on all 3 of them at the same time. And by the way, all 3 of these meters are 4000 count, so they have the same resolution, all 3 of them. So this voltage reference is based on AD584 chip, just like this one as well. They use the same chip, although one of them is marked AD. One of the chips in one of the boards is marked AD, Analog Devices, which I guess is the original manufacturer, and the other one is marked Max, which I guess it may be some knockoff brand, or maybe it's one of the major manufacturers. Maxim, I think, is I don't know whether they clone the AD device or what, where they officially do that, or maybe it's just some Chinese knockoff. I don't know, but they seem to be both working fine. One thing that you need to be aware of is that you should keep them powered on for a good while to let them warm up and get to operating temperature and operating range. So they should be plugged in and powered on for extended period of time. I kept these 2 turned on for several hours, and I also kept all my meters on for several hours, just so again they just get into their full operating range and work right. So this reference board was $7, and the fancier one, this one right here, was $16. So again, not a big expense for what you get, and I think that it's a fairly good tool that it's nice to have in your lab. Of course, you can spend a lot more money on much better voltage sources or reference sources. Some of them come with not only voltage reference, but also current references, resistance reference, and some other references that you can use to test your meter. These only supply voltage, but that will do for now. So as you can see, really to my surprise, this cheapest meter is spot on. I have my reference board on a 10 volt output range, and this Mastech meter has been displaying 10 volts even all along the entire period of time that it's been on. It's staying firm on 10 volts even. My Micronta, which I expected to be the most precise, is actually floating between 10 volts even and 10.01. So it's pretty close, but not spot on. Now, the Victor, which actually, so Micronta I bought originally for $100. I don't know if at makes any difference, but that's the point of reference. The cheapest, the most expensive one, but slightly older, so maybe it's just going out of calibration because of its age. And then this one, as you can see, is 0.03 of a volt off, or 30 millivolts off of the exact measurement. And these boards actually come with, well, this particular one came with a little sheet showing the measurements that were taken on a very precise Agilent 34401A meter. So they basically plugged in this board into this meter and made the measurements on each of the 4 ranges and noted what this meter measured. And so I should expect to be getting 10.00066 volt out of this board as measured by this Agilent meter. I'm not sure if I can trust this, whether in fact a good meter was being used in manufacture, but hopefully that is the case, and that is the voltage that was measured originally at the factory. That's measured at certain temperature. Unfortunately, I don't read Chinese, so I'm not sure what all this says. I should probably translate that to make sure, but I might guess that maybe that was measured at 23 degrees Celsius, which I think is around 75 degrees Fahrenheit, which I keep my temperature here around 70, 73, so fairly close to that. So if there is any difference caused by temperature difference, it should be negligible. So I'm hoping that I in fact am getting 10.00066 volt on this range. So I'm really happy that this meter, the cheapest one of them, is actually showing the precise measurement that I'm expecting. And my Victor, I was actually hoping this one would be the more precise one, or better adjusted one. But I guess I will have to open it up and calibrate it. So there will be another video, actually for both of these meters. I'll open them up and I will try to calibrate this one. And I may even take apart this one just for completeness of showing you guys what all these meters have inside of them. And of course the other 2 meters that are still on their way to me will also have their videos of take apart and possibly calibration. So that's the 10 volt range. Let's switch to 7.5 volt. And I should be getting 7.50042 volts. So of course that's way outside of the precision of all these meters, but I'm expecting to get a reading of 7.500 volts on all 3 of these meters. So I'm going to unplug these 2 probes because they are kind of in my way. And to switch voltages, you just move these jumpers from one position to another. That's a little silly approach. I would like it better if they just used some kind of switch. But that's how this thing operates. And again, this is a bare bones board, really one of the cheapest available. So it is what it is. So let's plug in the probes and let's see the result. And again, Mastech, the cheapest of them all, is spot on, 7.50. Micronta, a little bit on the high side, 7.51 to 7.52. But still close enough. And again, I will probably take it apart and maybe calibrate it to 750. Why not? And Victor again is off by 20 millivolts. So again, it's measuring a little bit low and probably still within its advertised range of precision. It's probably, fine as far as how it should have been calibrated. But I think that it can be adjusted and tuned to be even more precise and be spot on. Why not? All right, so that's 7.5 volt. And now let's switch to the next range, which is 5 volt. And again, pop the clips or probe off, move the jumpers, plug in the probe, and let's see what we get. And we should be getting 5.000 reading. The sheet says the board should produce 5.00037 volt. So again, Mastech, spot on, 500. Micronta, again, a little on the high side, but probably still within spec, 5.03. And again, Victor, a little on the low side, but probably still within spec, 4.98 volt. So let's see what we get on 2.5 volt range. I should be getting a reading of 2.499. And I'm skipping the last two digits because that's beyond the resolution of my meters. So 2.497. Now Mastech is a little bit low. It's 3 millivolts on the low side, which still is fairly close, and that's the only range on which it's off. Micronta 2.494 flickering to 5, so about 5 millivolts off on the low side this time. It was on the high side on the previous readings. On this reading, on this range, it's on the low side. But and Victor 2.497, same as Mastech. So these two guys are both on the low side this time, and both are off by 3 millivolts, which is very close to the voltage that I'm expecting, and I think it's actually pretty good. So that's this little board. Now let's try to use the fancy one and see how this compares to the readings that we got so far. So I'm going to unplug all these meters, and I'm not sure, I don't think I can plug in all 3 of them into this other board all at once. I may have to go one at a time. Now let me get this stuff out of the way. I probably wouldn't want this LiPo battery to short out on me here. That would be fun. But not in the way I want it. See? It just beeped on me. It just timed out. So I just push hold again. That resets the timer. And even though this hasn't beeped yet, but it's going to soon, so I just do the same thing on both of them, and that's out of the way. And by the way, this Mastech meter has a much louder beeper than Victor, which may be a good thing sometimes when you step away and want to be aware of it timing out. You know, you'll hear this better than this one. So here's Mastech, and here's Victor. Much quieter. It's probably that the speaker is hidden a little bit deeper in the case, and so that's why we don't hear it as loud. But back to the voltage reference. Let me see if I can figure out a way to plug in all of them. Well, one problem with this is that these connectors are actually for banana plugs, and they go all the way through to the board, and there are things on the PCB below them. So you don't want to stick your probes in too deep and maybe short out something. That, I think, is a flaw in the design of this voltage reference. It really should have nothing on the PCB underneath these connectors. There maybe should even be some sort of pad insulating or isolating the area on the board underneath these connectors. So I may have to go one at a time unless I can find some sort of banana plugs. Oh, there we go. Let's steal these probes from this little meter, and that's actually another meter that I'll post a video on later on. So this meter, this is a inductor and capacitance meter. This one came with these funny probes, and they actually had shrouds on them, but I had to chop them off because my old Micronta meter is old school meter, doesn't have these fancy connectors with shrouds on them. So in order to be able to plug in these cables into my old meter, I had to remove the shrouds. I just trimmed them off. And actually I just noticed the nice thing about these plugs is that they, on the inside, they are made of plastic. So this is a plastic tip, so actually I can stick that into this voltage reference and not worry about shorting out whatever is under the connectors there, because this plastic would touch that. Although I don't think that they will go deep enough for that to happen. Anyway, plug in negative, positive, and then let's see if I can do some trickery to connect all three of them all at once. That's one, the other, that will be tricky, but hopefully not impossible. And the clip. Alright, that's one. And now the same thing for the other one. Alright, and the clip. There we go. Hopefully this will hold. Alright, so we are on, and actually I was charging this little guy because it has a built-in battery. That is very nice. It has a built-in LiPo battery. Oh, the clip just popped off. Okay, so I wanted to charge it fully for this video, but now that I will be making measurements, I don't want the charger's noise to affect the voltage source, so I'm unplugging the charger and I'm running this thing off of the battery. So let's see. Victor is showing 2.496, Micronta 2.494, and Mastech 2.496. So agrees with Victor. And this voltage reference actually has the measurements on the bottom. So let's see. This should read 2.49916. 2.499. So this one is again 3 millivolt off, and so is this one, both Victor and Mastech. And Micronta is 5 to 6 millivolts off, all of them on the low side. Now to switch ranges on this reference, it's much nicer. You just push this button right here, and that flips us to the next range, which is 5 volts. And it should be, as measured, it should be 4.9979 or 4.99, I guess 7 or 8 rounded on these meters at this resolution. But that's not the reading that I'm getting. Mastech is 1 count too high, or 10 millivolts too high. Micronta is 3 or 30 millivolts too high, and Victor is 10 millivolts low. So actually Victor this time is closest. Well, both Victor and Mastech are close, just in opposite directions. One count off, but in opposite directions. Okay, let's see the next range. That should be 7.5 volts, and as measured at the factory, that should be 7.496. So 7.49. About 20 millivolts on the low side on Victor. Yeah, 7.49. Okay. About 20 millivolts on the high side for Micronta, and 10 millivolts. Well, It's almost spot on. About 10 millivolts on the high side for Mastech, but it's very close. It's like right on the edge there. Let's see, 10 volts. Okay, and the measurement that we should see, or the reading that we should see, should be 9.99 volts. 9.997, so 20 millivolts on the low side, 10 millivolts on the high side, and 10 millivolts on the high side, although again right on the edge. So surprisingly, this Mastech meter is the closest to the correct measurements of the three, and this is the cheapest meter. But I'm hoping that with some calibration, my Victor and Micronta will be also spot on, and we'll see how the two more meters that are on their way, how they will do with these measurements. That's it for today. In the future videos, take aparts and reviews of each meter individually, and see you guys later.